Suppose n lines are drawn where no 3 lines are concurrent and no 2 are parallels. Then how many zones we can get? This is the question which is asked by a student last night, and it's a fantastic question, I think. So, how to proceed? At first, I am starting with a very simple example. Let it's a plane and I am drawing one line. And the line will divide the plane into two portions. So, there exist two zones. It is 1 and it is 2. If I draw another line, then how many portions are there? 4 portions. Zone 1, zone 2, zone 3 and zone 4. Now, if I draw another line here, then we will get another subzone, but it is not possible to count that zone with that numerics, that is 1, 2, 3, 4, 5, 6, 7, 8. So that is why we are required to find a solid method to find the zones. Look at here, for this third line, the third line is intersected by two lines. As no 3 lines are concurrent and no 2 are parallel, so third line is intersected by other 2 lines. And these 2 intersected portion divides the third line into three segments also. One is L1, one is L2 and one is L3. Now, look at here. All this segment is passing through the previous region. That means L1 is passing through 2. And when L1 is passing through 2, then L1 is giving, or L1 is dividing zone 2 into 2 parts. So L1 is giving a new zone for L2. L2 is, when L2 is passing through 3, then L2 is giving a new zone. It was previously it was 3. Now when L2 is passing, there are 2 zones. One is this one and one is that. Similarly, L3 is giving another zone when it is passing through the 4. Now, if I draw another line, this is line number 4. That line number 4 is intersected by 3 lines. So, as the number of point of intersection is 3, so therefore, number of line segment is definitely 4. And each line segment is passing through a zone and which is giving a new zone. Now, following this type, if you form a recursion, that is Tn is number of zone when n lines are drawn, and Tn minus 1 number of zone when n minus 1 lines are drawn. It is equal to n. Why? Because nth line, mind it, nth line is intersected by n minus 1 number of lines to create n line segment, and every such segment is moving through a zone and providing a new zone. That means, as we have n line segments, so we will get n new zone. So, if Tn minus 1 is number of zone when n minus 1 lines are drawn, and Tn number of zone when n lines are drawn, so their difference has to be equal to n. So, this is the equation of recursion. Now, if I solve the equation of recursion by telescoping technique, that is sigma Tn minus 1, where it is n equal to 2 to n, then definitely we will get Tn minus T1 equal to 2 plus 3 up to n. And from here we will get Tn equal to T1 plus 2 plus 3 up to n. Now T1 equal to 2, because if I draw one line that will divide the segment into two portions. So overall Tn equal to 1 plus sigma